This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss some technology solutions and problem extensions for the 2017 AP Calculus exam, Free Response Question BC5. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I am a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. And I'll focus on the solutions presented in these guidelines, not how the points were awarded. Now, even though this question was not calculator active, I'll show you how to use technology to explore and solve parts of this question where appropriate. And because the free response questions are usually very comprehensive, I'll suggest some problem extensions. These are additional AP Calculus type questions associated with the information given in the problem. And some of these questions may be calculator active. In this problem, we're given a rational function f. In part A, we need to find the slope of the line tangent to the graph of f at x equals 3. In part B, we need to find the x-coordinates of all the critical points of f in the interval 1 to 2.5, and then classify each as the location of a relative minimum, relative maximum, or neither. In part C, students were asked to use the partial fraction decomposition of the function f to evaluate an improper integral. And in part D, students were asked to determine whether a related series converges or diverges. Part A was worth 2 points for finding the value of the derivative of f at x equals 3. Well, there are really two natural calculus steps here. First, find the general expression for f prime of x, and then evaluate this expression at x equals 3. Part B was worth 2 points. 1 point for finding the x-coordinate of the only critical point in the interval 1 to 2.5. And to find this value, set the derivative equal to 0 and solve for x. And 1 point for stating that this is the location of a relative maximum with appropriate justification. Part C was worth 3 points. 1 point for finding an antiderivative, 1 point for using a limit expression appropriately, in general either attached to an integral or antiderivative. For example, here or here. And 1 point for finding the final answer. Part D was worth 2 points for determining the correct conclusion that the series converges, and for stating the conditions necessary to apply an appropriate test for convergence or divergence. Note that there are two solutions given in the scoring guidelines. The first involves the integral test, and the second involves the limit comparison test. To solve part A, start by rewriting the expression for f, because it's easier to use just the chain rule to find the derivative, and not the quotient rule. Find the derivative, and then evaluate f prime of x at x equals 3. And here's a technology solution. Define the function f, and evaluate the derivative at x equals 3. Now, using technology, I don't have to explicitly find f prime of x, but I included that step here to demonstrate how the TI-Nspire can actually find the symbolic derivative. Here's a problem extension to part A. First, write an equation for the tangent line to the graph of y equals f of x at the point where x equals 3. And then use this equation of the tangent line to approximate f of 3.2. And determine whether this approximation is an overestimate or an underestimate. And don't forget the justification. To find an equation for the tangent line, we need a point and the slope. Well, we already have the slope. To find the point, evaluate the function f at x equals 3. So here's an equation of the tangent line to the graph of f at the point where x equals 3. And using technology, here's a visualization of this solution. To find an approximation for f of 3.2, evaluate the tangent line function at 3.2, and the approximation is 3/4. Using technology, I found and stored both the slope and f of 3 labeled as b here. The tangent line function is defined here, and the approximation is 0.75. And here's a visualization of this approximation. This graph suggests that the approximation is an underestimate, but of course we need more precise justification. To determine whether the approximation is an underestimate or an overestimate, consider the concavity of the graph of f, and therefore the second derivative. Now, it might take a little thought, but each term in this expression is positive for x greater than 5/2. So, f double prime of x is greater than 0 for x greater than 5/2, and therefore the graph of f is concave up for x greater than 5/2. And so finally, the approximation is an underestimate. Here, I use technology to find the second derivative. And to help me determine the sign of the second derivative, I wrote this expression in factored form. To solve part B of the free response question, set the first derivative of f equal to 0 and solve for x. The only critical point in the interval 1 to 2.5 has x coordinates 7/4. Now, personally, I would then construct a sign chart to determine the behavior of f prime near x equals 7/4. And the conclusion is that f prime changes sign from positive to negative at x equals 7/4, and therefore f has a relative maximum at x equals 7/4. Here is some technology help with this solution. In this step, I solved the equation f prime of x equals 0 for x in the interval 1 to 2.5. And here I found the second derivative of f at x equals 7/4. Since this value is negative, the graph of f is concave down at the point with x equals 7/4. And therefore f has a relative maximum at x equals 7/4. And for additional confirmation and visualization, this is a graph of f prime near x equals 7/4. Although not sufficient justification, this graph does support our conclusion. The graph suggests that f prime changes sign from positive to negative at x equals 7/4. And once again, therefore f has a relative maximum at x equals 7/4. Here's another problem extension. And let's do a little more with the function f given in the statement of the free response question. First, consider the entire domain of the function f. Are there any other critical points of f? And if so, classify each. And if not, why not? Find all the horizontal and vertical asymptotes on the graph of f. And find the intervals on which the graph of f is concave up or concave down. And find the inflection points. Oh, and I'm going to leave this problem for you to answer. In part C of the free response question, I wanted to make some comments about the partial fraction decomposition, which was given in the statement of the question. However, in our classes, we probably ask students to find the partial fraction decomposition. Now, in this case, the denominator of f is the product of two unique linear factors, both raised to the first power. So the PFD must be in this form. To solve for the constants a and b, we find a common denominator on the right side, which is the product of the linear factors. Then the left and the right rational functions are equal, and both have the same denominator. Therefore, the numerators must be equal. In general, we can distribute on the right side, collect like terms, and then equate coefficients. And this leads to a system of simultaneous equations. In this case, it would be two equations in two unknowns. However, in this case, we can find the values of the constants a and b by selecting judicious values for x, the root of each linear equation. If x equals 1, we find that b equals -1. And for x equal 5/2, we have a equals 2. And finally, here's the partial fraction decomposition. With technology, the TI-Nspire can find the PFD very quickly. Now remember, I already have f defined. So on a calculator page, I used the command expand. And the result is the PFD. Pretty cool. And I can even find the value of the improper integral. Even cooler. Yes, there's a negative sign in front here. But notice that the argument is 5/8, not 8/5. In part D of the free response question, I want to use technology to investigate whether the series converges or diverges, graphically and numerically. So here's a graph of the terms of the series and the partial sums. And here's a small table of values of partial sums. Remember, neither is sufficient justification that the series converges, but both support the rule of 4 and help us to explore and confirm results. And here's one more problem extension for your consideration. Consider the series presented in part D of the free response question. Find the 20th partial sum, that is S sub 20. Use the remainder estimate for the integral test to estimate the error in using S sub 20 as an approximation to the sum of the series. And finally, try to find a value of n so that S sub n is within 0.0001 of the sum of the series. I hope this video gives you some good ideas for additional practice AP Calculus exam type questions and of how to use technology to solve some of the parts of this problem, to explore, confirm, and visualize results. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.